there, welcome to my class. Today in this class we are going to discuss about the Bluetooth technology. We are all very much aware that the Bluetooth is penetrating everywhere because it comes under the wireless personal area network. So even in your all smart devices we used to have our Bluetooth. So in this Bluetooth topic what we are going to discuss is what is the use of that Bluetooth, and what is the structure of a Bluetooth, and then what are all the evolution. So when it starts from Bluetooth version 1 to Bluetooth version 5, right now what we are using it, so up to that Bluetooth 5. So what is that profiles? It means that when it has been evolved, and what is the data rate it can able to support, and in which are all the technologies which is going to support this Bluetooth technology. And then we will be seeing some two important architecture of Bluetooth, that is Piconet as well as a Scatternet. In this Piconet as well as a Scatternet, how the devices can be able to connect. And then we will be seeing that Bluetooth protocol stack, and as like how OSI and TCP IP, how the protocol stack is there in Bluetooth technology. That is also we are going to see. And then we will see some of the frame formats. So say for example, link layer authentication protocol, L2 CAP protocol frame format, and Bluetooth packet frame format. All these things we are going to see in this class. So they all know that this Bluetooth technology, it comes under the personal, it is a local area network. So which in turns it is going to use that radio waves. That means that wireless local area technology, WLAN technology. So here this Bluetooth technology, which is going to connect the devices of the different functions at a shorter distance. So it does not mean that only that connecting, there is no restriction for connecting the devices and exchanging that type of informations. Say for example, in your mobile also you can able to connect to two mobiles, or else you can connect your mobile phone and as well as a tablet, and you can exchange any kind of information as like your data files, audio files, video files, animation. So whatever the kind of files you can able to exchange it. So to connect the devices of a different functions, but there is only one restriction, which is going to operate in a very shorter distance, because how much distance the Bluetooth technology which is going to work, up to that distance you can able to exchange that information. So it is going to be a shorter distance only. So this Bluetooth WLAN, we know that it is in a wireless category. So in this wireless also, we all aware of that there are two types of architecture. One is in infrastructure based, another one is an infrastructure less. If it is going to be an infrastructure less, then automatically it comes under a ad hoc in network. So it comes under ad hoc in nature. On the go you can able to develop your own network, and you can do some data exchange, data communication, and then you can tear off that connections. Say for example, by connecting easily, we can connect to two mobile phones, or two mobile and one laptop. You can connect and you can exchange, and then immediately you can able to disconnect it. There is no need for any other networking connecting devices. So on the go you can able to develop your own network. That is why it is called it as an ad hoc network category. So what are all the devices you can able to connect? So whichever the devices, by default, whichever the devices can have a Bluetooth technology transceiver, it's capable of communicating, then all that devices you can able to make a connection. So we are all aware that the desktop we have and laptop and smartphone, tablet, and nowadays the many sensors which has been embedded with a Bluetooth technology. That is where the IoT technology, which is a tremendously, it is exchanging information to some of the local servers. So from that the data are going to be pushed into that some cloudy environment. So as I said, there are two types of architectures which is going to be used in Bluetooth. That architectures are Piconet and the Scatternet. We all aware that the Piconet, which can able to connect a maximum of 7 devices in a single network. Whereas if you want to connect a multiple number of systems, I want to connect more than that of 7 devices in a single Bluetooth network, then you have to go with an Scatternet. Now we are going to see how the Piconet architecture, how the Scatternet architecture, and how you can able to connect one Piconet to the another Piconet. All such things we will be seeing with some beautiful diagrams, and how it has been evolved Bluetooth. So it has been start with the Bluetooth version 1, and then Bluetooth version 2, 3, 4, and 5. So the major difference what we are right now, what we are seeing it, Bluetooth version 1, which was invented in the year 1999, and this was this maximum speed rate of data exchange is 1 Mbps, and then Bluetooth version 2, which was 3 Mbps data rate. Bluetooth version 3 and 4 both are 24 Mbps. But the thing is that when the Bluetooth version 4 it comes, then low power energy devices. Whereas up to that Bluetooth version 1, 2, and 3, it consumes a huge energy. So that is the reason Bluetooth version 4 onwards, the 24 Mbps of data rate, as well as which is going to consume a very less in energy. If you have been used 10 years back, whatever the Bluetooth version 2, which was embedded on any mobile devices, if you connect a Bluetooth for a shorter time itself, it is going to drain your battery. But whereas nowadays you can see that even mobile generation 4 onwards, we are using it Bluetooth version 4 and above. So there even you connect a continuously Bluetooth also, which is going to consume a very less of energy. So Bluetooth version 4 and Bluetooth version 5, which is a data rate of 50 Mbps. So in this diagram you can see that which are all the years which has been introduced, and what is the version and what are all the major features we can see. So as I said, in 1999 Bluetooth version 1 has been evolved, and then Bluetooth version 2 is 2004, which was enhanced data rate of, that is a 3 Mbps data rate, and then a 2.1 in the year 2007, which is a secure simple pairing. So they introduced some of the security mechanism for Bluetooth, and then in the year 2007 with the Bluetooth version 2.1, and then 2009 version 3 with a high speed, that is with a radio, that is whatever the radio we usually used in WLAN, the same we are going to use, but the data rate has been tremendously increased when compared to Bluetooth version 1 and 2. That was 24 Mbps, but it was consuming huge energy. That is the reason in the year 2010 itself they introduced Bluetooth version 4, which consumes a low energy protocol, which consumes a very less energy with the same data rate, 24 Mbps. And then 2013 4.1, which support for indirect IoT device connections, and then 2014 4.2, which supports from IP version 4 to IP version 6 protocol for direct internet connections. Even you can embed onto some of the sensors, and that devices could able to directly connect with your internet from 2014. In 2016 it was Bluetooth version 5 has been introduced, which was greatly supporting our IoT industrial version 4 cyber physical systems. That was a 4x of range, 2x of range. You can able to select your own capacity, whatever the data rate you want to select, you want to use. According to that you can set your Bluetooth devices. This is what the evolution of Bluetooth. Now we will see the architecture. As I said, there are two types of architecture. The first one is a Piconet. So the Piconet, normally the devices which we have configured as a primary and secondary devices. For a single Piconet, there must be only one primary devices and 6 to 7 secondary devices it can able to connect. For example, left hand side diagram, you can able to see that there is one Bluetooth devices which can able to connect your earphone, mouse, and your tablet, printer, and general headphone, and game, mobile, and keyboard. As like you can connect as much devices you can able to connect it. This is what a primary. So it was very quite interesting when you go for a second Scatternet. It means that you can able to connect one Piconet to the another Piconet, so that you can increase the number of devices in the Bluetooth network. See, left hand side you can see that whatever it has been shown, it has an yellow, that is in one Piconet, and right hand side one more Piconet is there. Now what I'm trying to do is I'm going to connect one Piconet to the another Piconet. We know that the one Piconet have 7 devices. Now I want to make it as a 7 plus another 3 devices. So one Piconet may not accommodate. So in that cases, the first Piconet may have a 1 primary and 6 to 7 secondaries are there. In that, whatever we have seen in that HDLC protocol, the data link layer, the systems are configured as a primary, secondary as well as combined systems. As like this, one device can able to act as both a primary as well as secondary. It means that one device in this one Piconet, it can act as a secondary. That same device, it can able to act as a primary for the another Piconet. So that with that, it can able to connect another 6 to 7 devices you can able to connect. But the thing is that it is an ad hoc network. If you keep on increasing the number of devices, then automatically there will be a lot of collision will occur, the performance will degrade. But the thing is that if it is going to be scheduled, rarely the data exchange is going to happen, then it is the best advice to go for an Scatternet kind of things. That is what the Scatternet network in the Bluetooth architecture. Now we can see that Bluetooth layers. Now we will see the Bluetooth protocol stack, and then we will see comparison with an OSI reference model. We are going to see that. See, this is an very simple architecture. It is not as like a similar to an OSI and TCP/IP, but anyhow we are going to comparing with and how this going to be, which are all the layers which is going to be compared with that things. In the bottom layer, as like physical layer, how it is there in that OSI as well as the TCP, the same way it is going to be a completely radio communication only, which is going to use. So directly we can coin the name as a radio layer. That is similar to a physical layer. So the radio signals, whatever we are using it for a Bluetooth technology, if we are going to use a WLAN technology, then it may be a 2.4 gigahertz or the 5 gigahertz frequency can be used. And then the next is an baseband layer, and after that you can see that it was very interesting, that one that is a L2CAP. That means that logical link control adaptation layer. As like you know that data link layer, we know that LLC and MAC, similarly it is going to have a logical link control adaptation layer. So that will be getting a data from the multiple profiles. So in Bluetooth, as we said, there are multiple functions are going to be adapted into that. So there are a lot of profiles you can able to create it. For example, our first diagram itself, we could able to see that it can able to connect a printer, it can able to connect your audio devices, video devices, your television you can able to connect. So any kind of devices you can able to connect it. So each one have its own profile. So that profile which will generate the data. So that data will comes to an L2CAP layer. So which has to provide. So L2CAP layers, the main responsibility is to provide the interface for all the data, that was whichever the applications which is used in that asynchronous connection link, whatever it has been used in the asynchronous connection link, just be used to tell that ACL connection, ACL link, and also which is going to provide the multiplexing between the higher layers. So higher layers, we may be having a multiple profiles. So each profile may create a different data. So all that data can be multiplexed and which can be sent to that next level. So it means that whatever the segmentation and reassembly, that kind of process also which has to be taken care by this L2CAP layers. So parallelly it has to support for audio as well as video and then common control. On the top of it there is an application layer. So this is what the Bluetooth protocol stack. Next, now we will see, now we are going to compare that how the BLE stack and OSI reference model, how it is going to work in that. So we know that the OSI reference model, it starts from application to the physical. So now let us start with bottom. So the physical layer, which is equivalent to that whatever is the radio layer, that means that the BLE physical layer, Bluetooth link layer, physical layer. And then next is then how OSI reference model we have in a MAC and LLC, that is in a data link layer here, which is going to use the link layer and the L2CAP layer. As I said, the L2CAP, which is going to provide the interface for all the data in the applications via the ACL link, as well as which is going to provide a multiplexing of all the application data. So link layer and L2CAP, which is going to work under the principles of the data link layer when you compare to an OSI reference model. And then next is an higher layers, that higher layers which will have a lot of profiles as well as the applications, which is going to generate a lot of functions. Here we have mentioned some of the protocols. It is not limited to only these profiles. Apart from that, there are a lot of applications profiles you can able to generate. So the first one is ATT. It is a attribute protocol, which is an attribute. So we can create our different for our application. We can create our own attributes. In that attributes protocol, that is an attribute protocol ATT, which was mentioned in ATT. And then a GAP, that is a generic attribute protocol. Generic attribute protocol, which is also called it as a GATT. So this is also in general generics, whatever it is there in that is going to list it out. And then SMP is a security. It is going to provide a security manager protocol. We all know that if you want to connect your any other mobile devices, then automatically you have to pair it first, and then sometimes you need to provide some authentication. So, and then whatever the data exchange which is going to happen via that encryption also. So that is the reason this SMP, that is in a security manager protocol, which provides authentication and a pairing as well as a encryption, which is going to provide. And then heart rate, that is HRP, is a heart rate profile. This heart rate profile is a communication which is going to provide a communication between the IoT devices. As we said, from Bluetooth version 4 onwards, the IoT is getting into major applications of this using this Bluetooth technology. So this heart rate profile, which enables the communication between the IoT devices with your Bluetooth. And then ANP, that is an alert notification. We all know that there are a lot of alerts are happening, and for that alert also you may be connected to your smartwatch. There you will get whatever the notification, all these things which is going to come. And apart from that, even that heart rate profile also, so which are all the applications of your smart band and wristwatch and your smart glass, all these things which comes under the HRP protocol. And then access codes which is going to be used in that frame formats. Right now we will see that L2CAP data packet format, that is very important in a data link layer. So the first field 2 bytes is going to be an length, as well as next 2 bytes are going to mention that channel ID, because how it is going to connect on what logic. Next we will be seeing that how the hopping of the frequency which is going to happening between primary and secondary, there you can identify that how the channel IDs are going to be provided. And then data and control is there in the L2CAP protocol. Now we can see that how one single secondary communication which is happening between one primary to the secondary. For example, here you can see that one primary is there and then one secondary is there. Now the primary which is going to hop a frequency, F0 to the secondary, and then the secondary will use the next frequency. It is not going to use the same frequency. It is hopping from one frequency to the another frequency. Now the secondary will communicate to the primary with the frequency of F1, and then again the primary wants to communicate. It is going to hopping into a next frequency, that is a F2, and then subsequently continuously whatever the communication which is going to happen for every time which is hopping from one frequency to the another frequency. This is how the communication is going to happen. Now in this picture you can understand that how one primary and multiple secondaries are going to be communicated. So to make it easy to understand, I have used one primary and two secondaries. Right now the first primary, what it is going to do is primary, which is going to select the first secondary with a 1 frequency f0, and then the secondary one, now it is sending in data with a frequency of f1, and the primary, because the primary is taking control of the overall that Bluetooth. So now the primary, which is going to hop the frequency to f2 to the secondary 2, and then the secondary 2 is now using the next hopping frequency of f3, and it is going to send the data. Likewise, so how many number of secondary devices are there? According to that, which is going to hopping a frequency from 1 to another frequency. Now we will see the frame format types. So here the central one, that is going to be a frame format. The first one is access code, which is a 72 bits, and then header is a 54, and then payload is going to be a 2745, the maximum. So access code, which have the preamble, which is going to for a preamble to inform that it tells that is the start of that Bluetooth frame, and then a synchronization word for synchronizing purpose between the primary and the secondary, and then the trailer bits for other control applications. And that is for access. And the header field, which consists of a 54, that will have a three sets they have. The first set is address. First one is an address, and then next to 4 bits are going to specify that what type it belongs to, and then a third one which is going to specify what is a flow control, and then automatic request ARQM, and then sequence queuing, that is a SEQN is for 1 bit, and then header fields. So similarly it will have a 3 sets, and then original payloads are going to be there. So this is what the Bluetooth frame format. So access code, which consists of a preamble, synchronization word, and then trailer, and then header fields, which consist of address, type, flow control, and ARQ and SEQN. Hope you understood the Bluetooth concept. So let me recap that whatever we have covered. So first we have discussed about what is an Bluetooth and which technology it belongs to. It comes under like a WLAN and then a wireless personal area network, and then its nature is an ad hoc in nature, infrastructureless network, and there are 2 types of architectures, Piconet and Scatternet. How you can able to connect devices in a Piconet as well as a Scatternet we have discussed, and then how it has been evolved from Bluetooth version 1 to the Bluetooth version 5. For each Bluetooth version, how it is going to, in which are all the technologies which is supporting, what type of data communication which is supporting. And then we discussed about the Piconet, how 7 devices can able to make a single Piconet, and then we saw that how you can able to connect one Piconet to the another Piconet, then the types of devices, primary and secondaries, and then how the frequencies are going to be hopped, how the communication is going to happen between the primary and secondary, and how the frequency which is going to hop from one frequency to the another frequency hopping, that also we have seen. Finally we saw that protocol stack, and we have compared with the Bluetooth protocol stack with the OSI reference model. At last, finally, the Bluetooth frame format and L2CAP frame format we have discussed in detail. So hope you understood the Bluetooth technology evolution and how it works. You understood very well. If you have any doubts, you please drop in the comment line. I'm happy to respond to your question. Thanks for watching my class. Have a great day. Thank you.